Hey everyone, I hope you had a wonderful Christmas and holiday season. It's been a while, but I'm back with a new video, one of the longest on the channel. It's the second in the Blueprint Visual Scripting tutorial series. It's an overall just an introduction to the Blueprint Visual Scripting system. We're going to create a third-person character with the ability to move with a mouse and keyboard or a game controller such as an Xbox or PlayStation controller. And while we do it, I'm going to discuss the basics of the Blueprint editor. In future videos, I'm going to go into much more depth and detail on various topics. One more note before I roll the video. Now, it's been a while since I've recorded, and I put my microphone in a spot a little bit closer to my keyboard and mouse than I usually do. And the result of that was those two things, as well as slight movement on my desk, anything sliding around, being a bit louder than usual. I did my best to reduce this in the editing process, but it's still a bit louder than usual. My intention was not to mix Unreal Engine tutorials with keyboard and mouse ASMR, but here we are. Overall, I don't think it's too distracting, and I hope you all enjoy the video. So I've opened up the Unreal Engine editor right here, and the first screen you will see is an Unreal Project Browser. You'll have a section where it will show you all of your recent projects once you've made one or more and start using them. Then you have a section here for creating a new project, and this is a 4.27. In a moment here, I will show you the differences between its launcher and the launcher for Unreal Engine 5 Early Access. But for this video, we're going to be working out of 4.27 just because it's more stable than UE5 Early Access. And I'm going to go ahead and click on Games here under this new project categories section. I'm clicking Next, and I'm going to select Third Person, because it's going to give us a mannequin character and some animations that we can use to set up our own character and, well, learn how that's done. Once I've done that, I'm going to click Next one more time, and here we have some project settings. You can set your project to be a C++ project. It'll enable you to use C++ code to create it and use it inside the engine. It also means that you're starting blueprints. In this example, we selected a third-person template, so the third-person character will be C++ instead of Blueprint. We're going to keep ours set to Blueprints because that is the focus of this series. I'm not going to change the quality settings. Ray tracing disabled is fine. We're going to keep this on desktop/console. The other option here is mobile/tablet. Then here we have starter content. I'm going to go ahead and enable that, and that's just some basic content, some 3D objects and things that might be useful further on in the series to work with. And here you can choose a file location. And give it a name. In this case, I'm going to name it Blueprint Tut Series. There we go. And now I'm going to click Create Project. Here you can see the Unreal Engine 5 Project Browser. It's much cleaner, and all of those settings are now condensed onto a single page, which I think is much better. All of our drop-downs and menus and settings that took up an entire page or section of this are now condensed down to this area. Our different project types are here, and for switching our type of project, we have this bar over on the side here. Other than the changes in the location of the elements and the drop-downs, checkboxes, all that stuff, the process is exactly the same as it is in Unreal Engine 4. So, our Unreal Engine 4 project has loaded, and you can click play, and there's already a super basic third-person character here. I can use the WASD or gamepad joysticks to control. But we are going to be creating our own character that is pretty much just like this one. And I will be doing my best to teach you guys the basics of the Blueprint editor and what you can do inside of it along the way. So, every Unreal Engine project has a content browser and a content folder. And in this case, we have the starting content that comes with the third person example, and we also have that starter content that I enabled here. So I'm going to right click and create a new folder, and I'm going to name it Blueprint Tutorials. I'm gonna click it to enter it. And now there are two ways to create a new type of object inside of your content browser. You can right click and you have a menu here, or you can click add/import. Here we have a blueprint class option under this create basic asset section. I'm going to click it, and now we can see some of the main blueprint classes inside of Unreal Engine. There were a whole lot more, but 80 to 90% of the time you're just going to be using these. If you're not sure what a class or an object is, I recommend you watch the previous video in the series where I go over some of the basics of object-oriented programming. So I'm going to choose the character class, and I'm going to name it BP, which is for blueprint underscore third person character. Also going to do that one more underscore, and I'm going to add tutorial because there's already a BP third person character inside of this project. Now I'm going to open it up, and so there's the first thing you'll probably see is that there's a viewport here with what looks like a big sort of bean shape, and that is the collision capsule that comes with the character class, something that's inherited from the parent class object. And this handles collision. And for each thing you click in this viewport, it also shows up here in this components window. And right here, these are all the inherited components. We're going to cover them one at a time. So this capsule component, as I said before, handles collision, and each of these components has a details panel. And it might look like there's a whole lot of settings. There are. Most of these you won't be touching most of the time. And once you get to know the editor, the engine, it becomes a whole lot easier to understand what all of these different things mean and do. For the time being, we're not going to focus on any of the settings in the capsule's details panel, although I'll probably come back to cover some of them in a future video. We have an arrow component here, and all it does is it shows us what is forward for this character, so that when we add our mesh, our 3D object, we can make sure it is facing the correct direction. Now you notice we have a mesh here, but when we click it, we see this gizmo here, but there's no mesh here. And before we click it, there's not any sort of mesh either. The character class doesn't automatically inherit any sort of default starter mesh. We have to select our mesh over here in its details panel. It's under this mesh section, and we want to select a skeletal mesh with this drop down menu. We have two options which come with the third person example, a skeletal mesh mannequin and a skeletal mesh mannequin female. I'm going to choose the mannequin, and as you can see, it is facing the wrong direction and it is too high up. So what we can do is we can go over to this top section here, and we can click on this cube with the partial circle arrow thing around it, and that is the rotation button. It allows us to rotate objects around. However, we can also switch to it with the E key, one that we were on with the 4 arrows. That's to move objects around, and the third one here is to scale objects. And we can switch between all these with W for moving the object around, E for rotating the object, and R for scaling the object. I'm just going to Control Z to undo that scale there, and I'm going to press E to go back into rotation mode, and I'm going to click on this blue circle here, and I'm going to move my mouse until I've rotated it to -90 degrees. So now our mannequin is facing forward, but he's too high up. If I click on the capsule, and this details panel has this shape setting here, and I can see that the capsule half height is 88 units, which means that this midpoint of the capsule is 88 units down from the top and 88 units up from the bottom. So I can go and get into the mannequin, and I could move him down about to 80 there. But as you can see, it's in increments of 10. We can change that with this drop down here. We can go down to increments of 1 unit, and you can get there about 88, and it looks like that's not as far as we'll need to go. It's been a little while since I've set up a character from scratch. Or no, I must have misread that. I must have moved it down to 68, so disregard that. 88 is correct. But there's an easier way when we're trying to move something in an exact manner like that. I'm going to set this drop down back to 10, and you can see that we have this transform section in the mannequin skeletal meshes details panel. There's a location, a rotation, and a scale, and there's a value for each 3D axis. We can see that it says -88 in the Z. I can set that to 0. I could set that to 100. I could hover over these 2 arrows here and slide my mouse to slide between. I can do the same for all 3 of these axes for each one of these: location, rotation, scale. I'm just using Control Z to undo here. But that's another way to control the transform values, the location, the rotation, the scale of your character. So once the mannequin is facing in the correct direction, we're pretty much finished with our viewport here. We don't need to add any more components yet, but there is one more thing I want to go over briefly: the character movement component. And it is super important. It's the reason that we created a character class in the first place, because it's easy enough to add a capsule and a mesh component to any standard actor class with nothing here inherited. The character movement component allows us to alter all sorts of variables to control exactly how our character moves. It does various physics calculations, things like friction with the ground, maximum acceleration, rate of acceleration, maximum movement speeds and different movement modes. And it would be a whole lot to set up on our own without this movement component. But characters moving around is something so universal that Unreal Engine has helped us out by providing a class with a movement component that handles and does a whole lot of the heavy lifting for us. So there's another 2 tabs here. There's a construction script tab, and I'm not going to talk about this in this video. It deserves a video or more dedicated to it. So I'm just going to move straight on to the event graph. And now this is where you'll be spending most of your time in a blueprint editor. You have, this is where you lay out all your nodes and do all of your blueprint scripting. You can see that we have some events here to help us get started. These are in every blueprint at the start. We have a begin play, a begin overlap, and an event tick. Begin play fires an execution out of this pin. So if we had another node connected, it would tell this node, pretend node over here, hey, activate, do something, execute your code. Whenever we begin playing this actor begin overlap. So whenever you, if your actor or your object doesn't have collision and you overlap, so there's something else inside of it, this will fire off. And tick is a special one. It's called every frame. And this is where you run any code that needs to be constantly running and updated. Though if there's a way to run your code without using event tick, it's usually preferable so that you're not doing code every frame that you don't need to do. For the time being, we actually don't need any of these because all we want to do in this video is handle input. That's the first thing we're going to learn how to do. But before we can start adding nodes that deal with input, we need to know, well, how do we assign or create inputs inside of an Unreal Engine project? To do that, we go to Edit, Project Settings. It will open up a new window here. And this is where we have all our settings for a project. And this is one of the main things that changes depending on what sort of project you create. Like you saw, there's games categories, some categories for things like film or other non-game related things, and it's just a different sort of settings configuration and different starting content. So if you scroll down to there will be an engine section. Under it, about in the middle here, there's an input section. And the only thing we're going to focus on right now is the binding section. Here we have 2 types of input, action mappings and axis mappings. Because we have a third-person example project here, we already have action mappings and axis mappings. And before I teach you how to create one or set one up, or we look at any of these that are already here, I want to cover the differences between the two. An action mapping can give out a single value, a 1 or a 0, an on or an off. We're either jumping or we're not jumping. There's no value in between. And action mappings are best used with inputs that only use buttons, whether they be the face buttons on a controller or one of the mini keys on a keyboard. Axis mappings are a bit different. They allow for an on or off, but it's more of a, if the value is 0, it's off. If it's not 0, it's on, because you can have an entire range of values on an axis mapping. Think about the joystick or thumbstick on a controller. There's a lot of variation, a lot of possible positions, and if you are using a thumbstick to move a character around, well, we want to have control over the speed of the character with that thumbstick, and that is where an axis mapping might be useful. The same is true for a mouse, and looking around. We're not either moving the mouse or not moving the mouse. We can move the mouse at different speeds, so that's another case for using an axis mapping. To create an action mapping, We can hit the plus button here, and it will add a new entry to this list. We can name it action, and it gives us a single binding. We can hit this drop-down menu, and we can see that we have a ton of sections. We have a section for a gamepad, a section for a keyboard. For now, let's open up the keyboard section and click on E. But what if we want to add a binding for a controller, so we can either use a keyboard or a controller? Well, we can hit this plus button next to action, not the plus button next to action mappings. That'll give us another bind. And so now we could click on gamepad, and maybe we could type in something like right, face, and get gamepad face button right. For now, I'm going to delete this action mapping. We don't need any sort of extra button to take action to yet. So I'm going to, or I already have, click the X next to it to get rid of it. An axis mapping is similar. You can set keybinds, just like with action mappings, but usually you're going to be wanting to use a keybind of the type axis. It'll automatically give you that value from 0 to 1 or -1 to 1. I'm going to delete that new one again. We don't need it. And so let's take a look at move forward. We can see that it's actually set up to use buttons on the keyboard. And that's because we want to have variation in our speed, control over that if we're using a controller, but if we're using a keyboard, we don't have that, but do we want two different ways to handle input? Do we want two separate things, or would it be easier? Would it be better with just one? I think it's better with one, and the people at Epic Games developing the engine think so too. So you can assign a scale to an input on an axis mapping. What that will do is it'll affect the numerical output of the button or joystick or mouse. For an axis mapping, a button will always output a 1 when it's pressed, a 0 when it's not pressed. But we can give it a scale. We could take W and say, hey, your scale is 1, and S and say, hey, your scale is -1. Which now means that when you press or hold W, it outputs 1, S is -1. Just like when you're pushing up on the thumbstick, it's 1, and all the way down, it's -1. And so we've recreated that range, that axis, with 2 keys. And we can see that the same thing is being done with up and down, too. And so an axis is just a one-dimensional line. So we can only do our X movement in one axis mapping. We have to do our Y movement in the other. All right, I had to briefly pause recording, but now that I'm back, I believe I've covered all there is to cover for creating action and axis mappings. So we can close out of project settings. And now I'm going to show you how to implement them inside of a blueprint. In the event graph, we can right click and it opens up a menu. And this menu contains all the nodes we're able to place will function in this blueprint. If we wanted to see all the nodes in the engine, we could uncheck context sensitive. We're going to leave that checked because there's some things the character class can't do, and we don't want those things getting in the way. So to handle input, we want to create an input node. And to do that, we can just type in the name of our input, like our input axis move forward. And it gives us one of those event nodes again. It gives us an execution pin, which will tell code to execute to run. It gives us a value, which is our axis value. And this execution pin fires when there is an axis value that isn't 0. We're going to create one more input axis here, move right. And you want to make sure that you are clicking the one under axis events, not axis values. If you click axis value, it just gives you the value, this axis value here, allows you to use it. It doesn't give you the execution pin for the event to execute code. And off of this input axis, we want to execute code to move the character. So we can right click and we can create another node. And this node called add movement input. And it's a node that comes with the pawn class, and the character class actually inherits from the pawn and adds some of its own things like the character movement. The pawn class itself has the code for taking movement input and doing things with it. So we can click and drag from this move forward and connect the execution pin to this add movement input. But we need to tell it what direction to move in, and we also want to give it our axis value. So to do that, we have this scale value and this axis value, and you can see that they're both green, which means they can be plugged into each other. And now in Unreal Engine, this color green represents a value type of float, and a float is a variable type that can store numbers in floating point form, which allows you to store numbers with decimals. There are more details that I can go into. I could go deeper into floating points, but I'm going to save that for a future video on variables and variable types inside of Unreal Engine. I'm going to go through and explain most of them and their differences. For now, we just need to know that we're connecting light colors to each other. So we've given it our scale value, but you can see it's still asking for two more inputs. One, world direction. That makes sense. We need to figure out what direction we want the character to move in, because it knows that this is an input. It can give an axis value and whether it's on or off, but it doesn't store any information about where we want to go. And so that's the world direction. But there's also another input this is requiring, a target. And this is saying, who am I supposed to execute this code on or for? And the default is self, and that's what we want to leave it as. We're putting this code together inside the character, and so the target for this movement input should be the character that we're putting the code inside. If for some reason we're handling something inside of another blueprint, then we could add something different into the target, and there are situations where we would do things like that. One example is some sort of blueprint camera manager, where we manage a camera for our character, what we're looking through, and a completely different blueprint, a different actor class that's just to manage the camera. We want to do things with it and move it around and take away the player's control for cinematics. Then we might want to get a reference to a camera object and plug that into the self. For now, we can leave that blank. We don't need to get any sort of reference to an object. But if we needed to get a reference to an object, we'd right click and we'd type in the name of that object. And it would have to be a component in this blueprint. I could get the character movement component. And so when you're getting a reference to an object like that, it has to be an object that exists inside of the blueprint you're using. If it isn't, there are ways to access it, but that again is a topic for another video. As you can see, it's blue, and that's like an object reference color, but it tells us these aren't compatible because there are different types of objects. So we're going to delete that. We don't need it. We can leave target as self, and now we need to calculate our world direction. And to do that, we are going to use a little bit of math. So the first thing we want to do is we want to get the looking direction of the character. And we can do that by using a node that's a function called getControlRotation. And so this is a function, which means that it has this f by it, as you can see, this is a function too, actually, over here. And so this contains code that does things that we don't need to know how it does. This contains code that does things, but we don't need to know how the code works because it's not necessary for us doing what we want to do in this blueprint. It's an example of abstraction, one of the 4 pillars of object-oriented programming. We know that in any pawn class or class that inherits from pawn, we can use a get control rotation that'll get the looking direction of our camera, which controls our character. And I've brought up a camera a couple of times, and you might be thinking, well, where is the camera? And this doesn't have one. We'll have to add one in. And I want to do that after we finish setting up our movement input. So, because this is a class inherits from pawn, I can use get control rotation. And it gives us this light purple value. And that is a rotation, a rotator, an Unreal Engine. And a rotator is a variable that contains 3 of these green values, floats. 1 for X, 1 for Y, and 1 for Z. I can drag out from it, and to access those floats, I can type in break rotator. And this is a sort of utility function that you can use in every blueprint that can separate rotators out into their 3 sort of values that are combined together and stored, that are stored together, not combined, to create them. Now, what we want to do is we want to get the Z rotation of the character, because the Z rotation is where we're looking horizontally left to right, not up and down. That would be pitch. And so what I want to do is I want to make rotator. It's the opposite of break rotator. It combines them back into a rotation value, but it's plugged into roll here automatically. So how do we change it? How do we make sure it's plugged into yaw? There are 2 ways. We could just drag out from yaw and plug that into yaw, but it's still plugged into roll. And if we try to drag out from roll, well, that doesn't really do anything. What you want to do to change where a pin is plugged into is you want to hold down Control, click, and hold. Release, and you'll get rid of it. Or you can release it into a different place that it can be plugged into, just by holding down Control. So once yaw is connected to yaw, we can then drag out from return value. And what we can do is we can get forward vector. And I'll explain what that does in a moment. But it's another utility math function that deals with values and Unreal Engine and allows you to do things with them. So to recap, we're getting our control rotation, we're breaking that rotator, and we're taking the yaw, our looking direction, our control rotation for left to right on a horizontal plane. Then we're making a rotator with 0 for roll, 0 for pitch, and our control rotation yaw for yaw. So we're saying we don't want to use roll or pitch to influence the direction our character moves in. Otherwise, if we look up and press W, we'll move straight up into the air. And now, this get forward vector takes the world forward vector. So if I open up Paint, and if I draw a line tool, a quick and messy sort of 3-dimensional thingy, I guess, you can see that we have these 3 directions, this up direction and our 2 sort of horizontal plane directions. One of the horizontals is X, one of the horizontals is y, and the vertical is z. And each of these directions can be thought of as a vector, an x, y, and z. X would be, so if it's a vector, which is made up of 3 floats, an x, a y, and a z, our x vector would be 1, 0, 0. Our y vector would be 0, 1, 0, and our z vector would be 0, 0, 1. And that's going to give us a direction. And what we want to do is we want to take our forward, our x or y, I can't remember which, it doesn't matter right now. So let's say x for the purpose of this example, our 1, 0, 0. We want to rotate that vector, that direction value, to face forward, the forward direction of our character. And so we take our rotation, our yaw, where we're pointing, and we say, get the forward vector, the x vector, and of the world, and rotate it, that value, so that it lines up with the facing direction of the character. And this is not rotating the actual world vector. This is taking the value, creating a new vector, and rotating it, so the world vector stays the same. And so if our character, let's say that he's this yellow line here, could be a little stick figure with incredibly short arms and legs and an incredibly long torso, and he is facing this way, something like that. Well, we know that he's rotated, so we take this vector, we rotate it to the yaw of the character, and now it's pointing this way. I hope that example helped. And so that is what the get forward vector does. We can plug that into world direction. And now we need to do something very similar for our move right. I can select add movement input, and I can either do Control-C to copy it and Control-V to paste it. I hit delete on my keyboard to delete it, or I could select it and hit Control-W, and that duplicates it. Or again, I could right click and add movement input and enter. Just different ways of getting nodes into your blueprint, to duplicating them, copying them, and pasting them. So let's grab the execution pin, plug that in, and now we can use mostly the same code here. So we don't even need to duplicate it or copy it. We could just drag off from this make rotator, and now I can get a right vector. This is going to do the same thing. It's going to rotate the world right, left vector direction to our facing direction. So the exact same thing as forward, but it's the right vector, so rotating it by our yaw makes it point to our right. And so that will allow us to use our input axis, move right. And believe it or not, that is input handled completely for movement. There are other ways of doing it. This is only one way. There are certainly more advanced ways, but I'm not going to be covering those in this video. Instead, we're going to leave it like this, the way that the regular third-person character sets up, because it's a totally fine, perfectly functioning system. We're going to move on to handling our control input, because we're getting this control rotation, but we need to rotate our sort of controller. We need to get that rotation and use it to rotate things in the first place. And so, like add movement input, the pawn provides us with an add controller input function as well. 3 functions actually: a pitch, a roll, and a yaw. We want pitch, and we want yaw. as a target and a value. And so we can get our lookup input and our look and our, it's actually named turn input. You might have seen a lookup rate and turn rate inputs. They're slightly different, and I'm going to discuss them in a couple of minutes here. They have to do with using a joystick instead of a mouse, or I mean a thumbstick instead of a mouse, when you're using a gamepad or controller. So now that we've added lookup and turn inputs, we now, before we go in and try out our new character, we need a camera. So let's go back into the viewport so we can see what we're doing, and we can add a component. We can add a camera component. Now we can raise this camera up to be head level. Yeah, sure, let's say shoulder level. We can move it back some. I'm gonna say 250 units is good. And now there's a slightly more complex way of adding a camera that links it to the character with like a sort of invisible arm, and that allows you to move the camera closer to the character if it's going to collide with geometry. But I'm going to cover that in depth in a future video. For now, I'm just going to drag and drop a camera in here. And now, if I go into the Blueprint tutorials, into this third-person character, oh, and I forgot to mention, once you're done creating your code, you want to click compile, otherwise it won't update things. And then it's a good idea to click save, just to make sure you don't lose any of your progress if the engine for some reason crashes at some point. So now that I've dragged my character in, I want to delete this old character. And now, if we go to details and type auto possessed, and it looks like caps lock is on, we have this option that comes with a pawn or any class that inherits from it called auto possessed player. We're going to select player 0. Just do that for now. I will explain it in more detail again in a future video. Now that we've done that, it means that when we click play, it'll automatically possess this character. And now, as you can see, if I move my mouse, we can rotate. WASD, we can move around. If I move my mouse up and down, nothing is happening. And we see as we rotate, well, the character is rotating with us. So what's going on here? Well, by default, the mouse is the character movement component, and the character class itself is set up to have the mouse rotate the character. And by doing this, it also rotates the camera. But it's not set up for the character to rotate with the pitch, and so we're locked up there and can't rotate the mouse like that. And the reason it's doing that is because this controller pitch and yaw input automatically try to rotate the character. But there's a setting in the details panel that says, hey, you're not allowed to give this character pitch rotation. So if we click on this third person character, and in the details panel, I type, let's see, rotation, you can see we have these 3 settings. Use controller rotation pitch, use controller rotation yaw, and use controller rotation roll. So you can see controller rotation yaw is enabled, and that's why when we rotate or move our mouse from side to side, it rotates our character. Now we could click pitch, and I'm going to do that just to show you guys what it does. And now, well, we can look up and down, but we move our character. So this is not a solution to our problem. Is there a way to fix this? Yes, there is. You can uncheck use controller rotation pitch, and the key to this is in our camera's details panel. We can search use pawn control rotation. And what it does is that if the camera component is placed on a pawn, should it use the view/control rotation of the pawn where possible? And that's yes, which means that we now want to rotate the camera by our control rotation. And so once we do that, we can look up and down. And it looks like, well, camera's acting a bit weird, and that is my fault. We should have added that invisible arm. I misremembered something and thought we'd be able to do this without it. So let's click the capsule component, add component. We want to add a spring arm. It's the invisible arm I talked about. We can raise it up some. And now I can click this camera and drag it to the spring arm and attach it to it. So way back here, so we need to take our transform and reset that so that we're not negative 250 on the X, because once we attach it to the spring arm, it attaches it to the point here. Again, I apologize about that. I can uncheck use control rotation on the camera, and that same value is there in the spring arm. I will cover the spring arm and what it can do in more depth in a future video though. So now if we click play, we can move the camera up and down. When we rotate the camera, the character rotates. But now that's one type of rotating the character, one way to do it, but some games, or in some cases, you might not want that to happen. And so if we don't want the camera's right to left to rotate the character around, you can go to the BP third person character tutorial in the components, type in inherit again, or actually control, and uncheck use controller rotation. Yeah, now we can rotate the camera around the character. That's one way to do it, but I'm going to leave that checked. And you'll notice, well, our character doesn't have any animations. To do that, we have to tell the character what animations to use. And Unreal Engine has a blueprint type that's specifically for handling animations. And this type is an anim blueprint. This mesh has an option to use an anim class. We can click this and we can select third person anim BP. And that's just the default animation blueprint that comes with this third person example project, and that applies animations to our character. And it doesn't support any sort of strafing because a regular third person character isn't set up to strafe. Eventually we will be creating our own animation blueprint where strafing is allowed, where it's set up and it handles it. But if you want to see how to keep your character from strafing, if let's say you want to hold down D and you want the character to rotate to face that direction, it's pretty simple. All you need to do is click on your character movement component, and in the details panel, click orient rotation to movement. It's a lot of settings. You might even need to revisit this video in the future a couple times as you create characters. But the more you do it, the easier it is to remember. And the only reason I remember is because I've worked with these things so much that, well, it's become, I've just gotten used to it, and I'm able to remember these things. You'll get there too eventually. So we can move around, we can rotate our camera, and, well, there's one thing we can't do, and that is jump. And so let's add in that last input. But here is a challenge. I want you all to pause the video and see if you can figure out how to get the character to jump on your own. And I'll give you a hint. Again, it's another thing inherited from the pawn, just like move forward and looking around. And our input axis is called jump. So pause the video here and see if you can figure it out. If not, resume the video and I'll show you how. All right, so you can jump, get the character to jump just by grabbing the input, jumped. I'm sorry, no, that was not the input. The action event jump. And when it's pressed, drag out from that. And again, type in jump. And we can use the pawns or the character's basic jumping function. Now, spacebar makes the character jump. And now we have all the functionality of the regular third-person character with the added ability to strafe, even though it looks a little strange. And finally, the last thing we're going to do is we're going to set this up so that it also works, so that rotation also works with a gamepad. And now I will talk a little bit about why it's handled differently. A mouse, well, when you're moving the mouse and the value is changing, you're rotating the character. That's not always true with the gamepad and your thumbstick, because you can only push it so far. But once you're done pushing it, once you've hit that limit, you don't want to stop rotating. And by default, you could just use input axis look up and turn with a gamepad, and that wouldn't be a problem, because when you're pushed all the way in one direction on a gamepad, the value is 1 or -1, and so that would mean this keeps turning. But then you wouldn't be able to control your speed. That's the key. You cannot control the speed of your rotation once you hit that limit with a gamepad. While with the mouse, I can move it slowly, quickly. There's no limit where I stop moving the mouse, I keep moving, and I cannot control the speed. And that is why, by default in this project, Epic separated out the input for looking up and turning with the mouse and the controller. And so we can get our input for turn rate, and that is why it's called turn rate and not just turn. And we can get the input for look up rate. Now we can select both of these by clicking and dragging, Control C, Control V. And the way that we control the rate is with a variable. We want to multiply this axis value by our sensitivity settings. Now, we are not going to go and create a pause menu with a sensitivity setting, but we can over here in the My Blueprint panel, under the Components panel, click this Add button next to Variables. We can type Control Rotation Sensitivity. I cannot spell today at all. You can see that if we drag it out, it'll give us an option, get or set. We can click get, and while it's red, that's not a float. This is a boolean. It's a on or off, 0 or 1 type variable. So what we want to do is we want to delete that, click on it, and you can see variable type over here. We can click the drop down and select float. Again, I'll cover the other variable types in the next video. Now we can drag it out, and we can drag out from axis value. And instead of plugging it into add controller or pitch input, we can type in multiply. And we can select this float times float operator. Or this float times float, not operator, just operation. You can connect this up in between both of these, and I'll just plug in sensitivity to each of them. Now if we played with the controller, well, it wouldn't do anything here because I forgot to connect the execution pins. Now with them connected, it still wouldn't do anything because we haven't given sensitivity a default value of our own, so it's using 0 over here in its details panel. So we'll multiply our rotation by 0 and not rotate. So what we want to do is we just want to set that to 1. And that will be our default controller sensitivity. So now play, and pretending I have a controller, I'm moving my joystick. It's definitely not me moving my mouse around slowly at a constant rate, definitely not that. And our character is rotating. And so that is how we set up a basic third-person character inside of Unreal Engine 4. First off, I want to say thank you for sticking with this video for as long as you did. It was certainly a long one, and there are many more videos in this series to come, which thankfully won't be nearly as long on average as this one. Now, if you stuck around, consider subscribing and consider giving the video a like. It really helps the channel. Again, thank you for watching and sticking through it to the end, and I'll see you all in the next video.